All right, okay, question number 6. This says, a geometric transformation R maps the point 2, 1 onto minus 1, 2. Given that R is 0, P, Q, 0, calculate the values of P and Q. So R, the transformation R, which is 0, P, Q, 0, when it's applied to the point 2, 1, it becomes the point minus 1, 2. Now, for that reason alone, I already know the value of P and the value of Q. I already know that P is going to be minus 1 and Q is going to be positive 1. I know that. Why? Because when P is minus 1 and Q is positive 1, what that matrix does is that it interchanges the what? The X and Y coordinates, and it changes the sign of the new X coordinate. I know that. But we're asked to calculate the values. So let us show some form of calculation. I'm going to multiply the two matrices. So it's row by column. The first element in the row is 0 times the first element in the column, which is 2. 0 times 2 is 0. And then the second element in the row, P, by the second element in the column, 1. So that's plus P. Then I'm going to multiply the bottom row by the same column. Q times 2 is 2Q. And 0 times 1 is 0. Now, this would be equal to the matrix minus 1, 2. So therefore, up top we have P, down bottom we have 2Q, would be equal to minus 1, 2. So therefore, P is equal to minus 1 and 2Q, not 2P, 2Q. 2Q is equal to 2. Divide both sides by 2, and we get Q is equal to 1. So P is equal to minus 1, and Q is equal to positive 1. And R is actually an anticlockwise rotation of 90 degrees about the origin. Here's what B says. B says a translation T, which is RS, maps the point 5, 3 onto 1, 1. Determine the values of R and S. Now, everybody should remember that the matrix equation of translation, it is the point, which is what? 5, 3, plus T, which is what? RS, is going to give you the image, which is 1, 1. Let's add the two matrices. So matrices of the same order may be added by adding corresponding elements. So this is 5 plus R at the top and 3 plus S at the bottom. And this is equal to 1, 1. So therefore, 5 plus R is equal to 1. So that would make R is equal to 1 minus 5. R is equal to minus 4. Now 3 plus S is equal to 1. That would make S equal to 1 minus 3. And so S would be equal to minus 2. Now, next we're asked to determine the coordinates of the image of 8, 5 under the combined transformation R followed by T. Now, the first thing is that I'm going to show it to you why. T, for example, so first of all, the translation R followed by T would actually be TR. That's what it's supposed to be. So the combined transformation, to get a combined transformation, you multiply the two what? Transformation. The matrices representing the two transformations, you will multiply them together. But you always put the what? The last one first and the first one last. The problem with this is that T is, so this would be T, which is what? Minus 4 minus 2. Now multiplied by R, which is 0 minus 1, 1, 0. Now you see this is an impossibility. It cannot be done. It cannot be done. Because remember, you're told that two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. You can't multiply these like this. You could multiply it the other way around, which is RT, but you can't multiply it by what? TR. So most times whenever the translation is the last transformation, it cannot be done like this. So what you have to do is that you're going to have to do the transformations one at a time. So the first, so I'm going to erase this because it can't happen. You can't multiply them. And I'm going to do the transformations one at a time. So the first one is to apply R, which is 0 minus 1, 1, 0 to the point 8, 5. So what this matrix does is, as I said, if you want to, you can simply just what? Multiply the two matrices and get the answer. Meaning 0 times 8 is 0, minus 1 times 5 is minus 5. 1 times 8 is 8, and 0 times 5 is what? 0. So the answer is minus 5, 8. And so the point, which was what? 8, 5, under the transformation R becomes the point minus 5, 8. In other words, the X and Y coordinates interchange and the sign of the new X coordinate change. This transformation is an anticlockwise rotation of 90 degrees about the origin. Now, after we apply it to after we apply R, we now have to apply T. So the new point now is what? Minus 5, 8. And we're going to apply T to it. T is a translation. So with a translation, you add the matrices. And the translation is what? Minus 4, minus 2. Minus 4, minus 2. So this becomes minus 5, a positive times a negative is a negative, minus 4, and 8, minus 2. So this becomes minus 6, minus 9. Minus 9, if the signs are the same, you add and keep the sign. Minus 9, positive 6. So the point which is minus 5, 8 under t becomes the point -9, 6. All right. So what we were asked to do is we were asked to determine the coordinates of the point 8, 5 under the combined transformation r followed by t. And when we did, the final answer is -9, 6. So if we rotate this point, rotate this point 90 degrees in an anti-clockwise direction about the origin, and then translated the point -4, -2, it became the point -9, -6. All right, so this is question number 6 from the homework.